Welcome back, my dear friends. Very good morning, good afternoon, good evening to all of you. This is the last lecture for the TQM2 class under the NPTEL MOOC series, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. And I am sure that even though I should cover few things, it has been a long journey. There have been a lot of coverage of concepts, and I will try to wrap it up in the last few minutes, but I will discuss few pending issues and then basically go into the part for the closing this TQM2. Now, if you remember that we were discussing that as addition and deletion of variables, what is the change of the sum of the squares, whether you are going to accept or reject H naught, and that would be under either the t value, that is the t statistics, or the f value or the f distribution, and we will consider that accordingly. Now, we will consider standardized and studentized residuals. Many model builders prefer to work with scaled residuals. So, they are being scaled or normalized to a value, like you will be giving a marks for a course on a absolute scale or a relative scale. These scaled residuals often convey more information than do the ordinary residuals. So, the scaled residuals are the errors divided by the sigma square, and sigma square is basically hat, sigma square hat, or is basically the mean square root of the mean squares of the errors. These standardized results have mean 0 and approximately unit variance, because you are considering normality. So, obviously, this would be a consequence. They are useful in looking for outliers. Most of the standard residuals should write in the intervals of plus minus 3, considering that you are in a position to consider about 99.97 percentage of the variability, that is plus minus 3 sigma. And any observations with the standardized residuals outside the interval is potentially unusual, and there are outliers, they can be rejected or action can be taken accordingly. These outliers should be carefully examined, because they may represent something as simple as a data recording errors or something of a more serious concern, such as the region for the regressive variable space, where the fitted model is poor in its prediction. Like if you remember in the last part of the 39th lecture, I did mention the in sample and the out sample. So, the studentized residual would basically be considered using the ratio of the errors of the ith element divided by the square root of sigma square into 1 minus HII. So, what is that? I will come to that later. So, this is the standardized version of the values which you are taking for the errors, considering the covariances of beta A, beta J, but they are now standardized. The studentized residuals have constant variance, which is 1, regardless of the location where it is, what is the mean value of axis. In many situations, the variance of the residual stabilizes depending on more and more data you have. So, obviously, for less number of data, the variability, or considering the concept of consistency, would be very high. As you take more and more data, obviously they would be cluttering in around the mean more and more. In these cases, there may be little difference between the standardized and studentized residuals. The standardized and studentized residuals often convey equivalent information. However, because any point with the large residuals and large values of HII is potentially highly influential on the least square fit, examination of the studentized residuals is generally recommended in order to pass much more scientific comments about the observations. The prediction error sum of the squares. So, you want to predict the sum of the squares errors provides a useful residual scaling. So, you are basically want to scale down the positive and negative fluctuations, and you want to predict it. To calculate this value, we select an observation for any random observation ith 1. We fit the regression model to the remaining n minus 1 observations, and use this equation to predict, and with that value predict that actual value of yi. I can be anything 1, 2, 3, 4, 5, 6 till n 1, and predict it with the corresponding hat value. Denoting this predicted value as y hat, we may find out the error. The prediction error is also called the ith error for the value of the prediction sum of the squares errors. This procedure is repeated for each and every observation 1, 2, 3, 4 till n, and obviously you will have the errors 1, suffix 1, suffix 2, suffix 3 till nth one, and you can find out that the sum of the squares of these errors, and that is exactly what I have been talking about. Find it for the nth plus 1, nth plus 2, nth plus 3 till whatever observations. So, square them up, sum them up. So, that error should be minimum. Thus, this predicted sum of the squares uses each possible set of n minus observations, and we can find out using the observations in such a way that an estimate data set can be utilized, and every observation in turn is used to form a prediction data set. It would initially seem that calculating this value requires fitting n different regression models. However, it is possible from the result that a single least square models can be utilized. So, you can utilize that and find it accordingly, the sum of the squares, and predict it accordingly. Residual sum of squares can be portioned into two categories. One is basically sum of the squares to the pure error, and sum of the squares due to lack of the fit. So, obviously, when you are trying to basically do that, so in a regression coefficient model, very simply consider that you have a prediction of betas. So, once you find out there would be error there, then once you use these betas to predict the y hat, there would be error here. Basically, there are two sets of errors. One is how good or bad your predictions or estimation, I should use the word estimation of these betas are there, and how good these estimated betas are able to predict the y hats. So, they are technically deviations or errors. I would not use the word errors, they are deviations, or they are differences in the actual value and the predicted value or the estimated value at two levels. One for the sets of betas, one for basically finding out the difference between the actual value of y and the predicted value of y. And even though it is not part of the course, I would like to mention that some studies had been done by Zellner using the balance loss functions, and those basically give you some idea on those lines. Suppose we have n observations on the response of the ith variable. So, we can find out y I and denote the y I j. So, jth observation on the response for x 1 x I 1 2 3 4 till k, and j's are basically outside this n set of observations which you have. So, based on that you can find out the errors, and once the errors are found out, you can find out that the sum of the squares of there were some lack of fit and some are errors due to the fit. As I mentioned, finding out betas would have an error, finding out y would have an error, we can find it out accordingly. So, this sum of the squares of the square lacks of fit would be given by n I, which is the observations which you are going to take, and the difference between the mean value. So, what you have actually, so you have the best fit line. So, from there you are trying to basically find out what are the errors. So, y bar, this is the line which you have, and these y hats are the predicted values. So, technically there are two sets. So, one is, let me use, this is, it will be easier for me to explain and for you to understand. So, this is x and y in 2 dimension, it can be in 3 dimension also. Consider this room. So, y is going along towards the roof, x 1 is coming towards me from one point, and x 2 is going from my left to the right. So, it can be higher dimension also. So, best fit line, let me fit a color, this is y hat, these are actual y, actual y means y, and these are the predicted y. So, use the pen and a dotted one. Let me check. So, this is the first reading, this is the second reading, third reading, fourth reading, fifth reading, sixth reading, seventh reading. For any one, you see the green and the blue. So, green is the actual y, green, and the circle one is basically hat, blue. So, based on that you can find out how the best fit is. So, how close or far you have been able to predict. So, if you remember, I mentioned find out the betas, find out the errors there, find out the y's, find out the errors. So, you are basically trying to differentiate the errors. So, the sum of the square of the lack of the fit is the weighted sum of the squares deviations between the mean response y bar at each level of xi and the corresponding fitted value. If the fitted value y hat are close to the corresponding average, then there is strong indication that the regression function is linear. If y hat deviate greatly from y bar, then it is likely the regression function is not linear, and you have to take decisions accordingly whether the model is right or wrong. The test statistics is again, it comes back to the sum of the squares of best fit and the error part, find out those ratios. That means, sum of the squares divided by the degrees of freedom, and find out those ratios will give you the f value under h naught, you reject or accept h naught accordingly. And the errors under this mean square for the best fit errors, predicting best fit errors, not predicting, can be found out accordingly depending on how many such betas which you have. If true, regression is linear, then the expected value of y should be equal to beta naught plus beta 1 x 1 1, beta 2 x 2 1, beta 3 x 3 1. So, the first number is basically the variable number, the next number is the reading number. So, 1 I am using if it is n plus 1, n plus 2, n plus 3, whatever it is. However, the true regression function is not linear, then obviously in that case the expected value would be either lower or higher. Furthermore, if the true regression function is linear, then the f test statistics and the h naught would follow a certain distribution, and its degrees of freedom would be m minus p and n minus m. So, m minus p, p is basically, remember, k or k plus 1, and n is the total reading which you have, m is the m as in mango is the new sets of observations you are taking. Therefore, to test for a lack of fit, we would compute the test statistics f naught and conclude the regression function is either linear or non-linear. So, before considering this experiment of random factors, so we will basically try to wrap up the overall content of the course. So, initially we did discuss what is a very simply what is a random variable, then we considered that considering a random variable, what are the moments, that means what are the dispersion concepts, what are the average tendency can be arithmetic mean, geometric mean, then harmonic mean, and they can be used to find out either the height or the weight of a group of students, trying to find out the average speed of a car, trying to find out the interest rate, flow of fluids in channels. Then we consider different type of the dispersions can be apart from the variances, you can have different type of standard deviations with respect to median also. Median is basically a central tendency where it divides the whole distribution into two equal halves of with probability 0.5, 0.5. Then later on we consider different type of discrete distributions and continuous distributions. In the discrete case, we considered the uniform discrete case, Poisson distribution, and so on and so forth. In the continuous case, we discussed the normal distribution, exponential distribution, and obviously we laid more stress on the normal distribution, because based on that we considered that three important sample distribution being chi-square, f distribution, and t distributions. And chi-square would basically be the relationship something to do with the second moment, and t and z would basically be something to do with the mean value, and f was basically something to do with the ratios of two different samples which you are going to take. I mentioned that considering CT1, CT2 producing two different products of the same type, and you want to basically find out the variability. So, you can use the F distribution. Then we went into the ANOVA table, and ANOVA table I mentioned time and again. I have been laying more stress in the last 10 or 15 lectures that your main emphasis is basically to find out the table wherein all the variables would be there. Then you will have the sum of the squares, then third column you have the degrees of freedom, in the fourth column you have the mean square values, the ratios of the total sum of squares by the degrees of freedom, then the F statistics, and then depending on alpha or p value you will basically comment whether you support H naught or reject H naught. We did discuss in different type of models, the fractional factorial models, whether the variables were basically attributes or continuous variables, and they would be of a type 2 to the power k or of third design, fourth design, depending on how you want to basically partition that. We consider different type of fold models. We consider different type of the assumptions where sigma square was considered to be fixed with respect to time. We did not consider the concept of the matrix, like this example came time and again in the regression part, that we did not discuss the points where the variances were changing and the mean values could change, but you would only consider them in the linearity model where betas was 0 or not 0. Then we consider the fold, the semi folds, and then we consider the block designs and how the block designs could be done in such a way that you can basically have the variables divided into blocks such that the prediction levels was fine, and they were the highest values. Values means that you want to basically reduce the error part and basically try to predict as fast as possible. Then we spend a lot of time about that if the factorial models can be 2 to the power k, 3 to the power k, and this 3 or 4 to the power k would basically be the level of differentiation of any variables, like it can be in the level of +1 0 -1, it can be in the level of +2 +1 0 -1 -2. So, obviously, in the first case you will have 3 to the power k, in the next case you will have 5 to the power k, it can be accordingly an even number also. Then we considered the different type of regression models, the concepts of betas, the assumptions which were there, the normality for x's, normality of y's, normality of the error terms, expected value of the errors being 0, variance being fixed, covariance existing between the x's and the errors was 0, obviously they have to be. Then we could discuss about the rank on the matrix and basically considered the combination of the regression models with the ANOVA models. This has been technically a long intense course, and I am sure that you have been able to tackle these assignments, and obviously you will definitely be able to do the final examinations in a much better way, considering that we have tried our level best to convey the concepts, and I am sure considering the level of confidence which all of you have within yourself, you will do very well. And for any queries whatever we have been able to our best level of satisfaction for almost all of you. So, as mentioned that for the regression models we considered the sum of the squares, and we also considered the sum of the squares had a predicted value which was basically R square. So, R square and adjacent R square also consider the standard format where the degrees of freedom were important, and degrees of freedom I did mention time and again what they were. We have, as I was mentioning also, that we have tried our level best to answer the queries through the forums, and for any help, any advice you need for this TQM2 lecture, you are most welcome to get in touch with NPTEL office, main office in IIT Madras, and we will from our side do our level best to answer the queries accordingly. And again I am saying the books, there have been many queries about the books and the slides, they are all taken from Montgomery's books, which is maybe costly, but there are very cheap editions of Montgomery available in the market and or in the library also, you can utilize that. Maybe the concept which you have considered maybe have been covered in the book in depth, but do not worry about that, lay only stress on the parts you have studied, or maybe you need not go into all the detailed parts, you can utilize this book and this lecture for TQM2 to the best possible benefit for all of you. to do good in TQM2 and also have an understanding of the design of the experiments, which is very important for trying to understand many of the decision making analysis from the point of view of statistics. With this, I will end this course, and I have a very nice day, and best of luck for all of you. And I am sure all of you will do very well in life. Thank you very much.